Hi, everybody. Welcome to 10.2 Parabolas. Yes, we are back to these things once again. Today we're going to take a look at how to write equations of parabolas in standard form and also graph parabolas. Now, earlier in the year we did parabolas of y in terms of x. Now we're going to do parabolas of x in terms of y. So first off, the next few sections here, we're going to be looking at things which are called a conic section. A conic section is described as any figure obtained by slicing a double cone. For instance, this is a double cone. If I take that double cone and I slice it, the object that is made is what we call a conic section. So slicing a cone in this manner gives us, as you can see here, a parabola. Slicing it this way would give me a circle. If I tilt that little slice a little bit, that's how we get the ellipse. And if I draw my slice so it hits both cones, I have what looks to be a parabola shape up here and a parabola shape up here, which is actually called a hyperbola. The actual definition of a parabola is defined as the set of all points in a plane that are the same distance from a given point called the focus and a given point called the directrix. Those two things are two things that we will find from the equation and then use to help graph the equation. So basically, a directrix is a line. A focus represents a point. The parabola then is all of the points in a plane that are equidistant or the same distance from that focus in that directrix. So if I calculate this distance and I calculate this distance, they're exactly the same. And that's true for any single point along that parabola. A couple other things about the parabola here that we're going to look to find is the latus rectum. The latus rectum is the line segment through the focus of a parabola and perpendicular to the axis of symmetry. So the axis of symmetry we've talked about before. Axis of symmetry is the line that goes through the vertex, and it's the line at which the parabola is symmetrical about. If I draw a line that is perpendicular to that axis of symmetry and at the same time goes through the focus of that parabola, that's what we call the latus rectum. The latus rectum has length of 1 over a being the number that's in front here of the x minus h squared. If you remember back when we studied parabolas, this equation was the equation of our vertex form. This is the equation we want to see things in. hk is going to represent your vertex. A, back then we just talked about whether it was positive or negative. If it was positive, told me the parabola opened up. If it was negative, meant the parabola opened down. Now it's also going to tell us the length of the latus rectum. And again, 1 over a, that is its length, which means the endpoints are 1 over 2a units from the focus. So here's everything that we need to know about parabola. These will make more sense as we actually go through and graph these, but the goal here is to get the equation to look like this. This is your vertex form. From this form, I can tell hk is the center or the vertex of that parabola. The axis of symmetry then is x equals h, is the line that runs through that point. The focus can be found by taking 1 over 4 times a. That's 1 over 4a, and adding it to k. The directrix can be found by taking k and subtracting 1 over 4a. Remember, the focus and the directrix, they're equidistant apart. So it makes sense that one you add and one you subtract. A, if it's positive, tells me it opens up. If it's negative, it opens down. And 1 over a is the length of our latus rectum. And remember, the latus rectum is the line that is perpendicular to the axis of symmetry and goes through the focus. Now, here's what's going to be new in this section. Parabolas don't have to open just up and down. Parabolas can open left and right. We didn't talk about them earlier because if it opens left or right, this means the parabola is not a function. So we kind of left this part out. But it can be that it opens in that direction. If it opens in that direction, the thing you're going to notice is instead of having an x squared, you're going to have a y squared. All the rest remains basically the same. So hk still my vertex, but notice where H and K are. H, K. H is the X, K is the Y. Axis symmetry will be now Y equals K. It's a horizontal line that goes to the vertex. The focus, I still add 1 over 4A, but now I add it to the H coordinate. The directrix, same thing. I subtract 1 over 4A still, but now I subtract it from the H. If A is positive, we open to the right, and if A is negative, we open to the left. Length of the latus rectum, that does not change. That is still your 1 over A. All right, let's give some of these a try. Write y equals x squared minus 2x minus 3 in standard form. We want to find the focus, the directrix, the axis symmetry, the vertex, and the length of the latus rectum, and then put it all on a graph. Okay, I brought a graph in here. To help us get from this, which is called general form, to standard form, if you remember way back when we dealt with quadratics, is to complete the square. To complete the square, we will, to refresh your memory, take the b term, divide it by 2, and then square both sides. So for this one, we'll go y equals x squared minus 2x, complete the square, so I take b, which is negative 2, divide by 2, which is negative 1, square it to get a positive 1. That's completing the square. Minus 3. Now, in order to keep things balanced, we have to add in what I just subtracted out. So, since I just added in, or sorry, I have to add back in what I just subtracted out. Since I added a 1 right here, to keep this balanced, I then have to go a minus 1. I don't want to change this equation at all. So plus 1, minus 1, they balance out. Now the reason why I complete the square is this is now something that's going to factor rather nicely, and it's going to factor into x minus 1 squared. Minus 1 minus 3 makes this minus 4. Now from here, this is all the information that I need. So first off, HK, the vertex, is a positive 1, negative 4. Positive 1, negative 4. So we'll graph that. Positive 1, negative 4. The next thing would be my focus. Where does my focus live? Well, the focus is at 1 over 4A above your vertex. So 1 over 4A gives me 1/4. So if I take this particular number and I add it to my vertex, it means my vertex is at 1, negative 3.75. I'll put a red dot there for my focus. Right about there. The directrix then is 1 over 4A less than your vertex. So the directrix becomes y equals, and I'll take my negative 4 and I'll subtract a quarter. So that means negative 4.25. And I'll draw my directrix. Now notice how my directrix is being drawn. Directrix is being drawn with a dotted line because it's not actually part of the graph. One more thing here, that would be to find the latus rectum. The latus rectum is a length of 1 over A. So 1 over 1 puts me at 1. By the way, I should have mentioned this before. A is the number that's in front here, remember? So A would be a positive 1. So 1 over 1 means your length of your latus rectum would be 1. And since the length is 1, that means from this focus, I will go 1/2 in each direction. And if I go 1/2 in each direction, that makes that entire length a length of 1. Once I have that information, I found the focus, I found the directrix, I found the vertex, I found the length of the latus rectum. The last thing in here that I can draw would be your axis of symmetry. Axis of symmetry, remember, will run directly through your vertex and is perpendicular to the latus rectum. So if I connect everything together that I have here, let's see how good I can do this with my mouse. Kind of missed that point, but there's your parabola. Vertex at 1, -4, focus at 1, -3.75, directrix at -4.25, axis of symmetry at 1, and the parabola is opening up. Okay, let's try one more here. Given x plus y squared equals 4y minus 1, I want to find the focus, directrix, axis, symmetry, vertex, and length of the axis of, length of the latus rectum, and then graph the parabola. So first thing I notice when I look at this equation is right here, y squared. That y squared tells me that this is in fact a parabola that shifts, that opens the other direction. So instead of opening up and down, this is going to open left and right. So first thing I'm going to do, I'm going to put the y squared on the side with the y. So this will give me the equation x equals a negative y squared plus 4y minus 1. Now, if you remember when you complete the square, the major rule here is you cannot have any other number other than 1 in front of the y squared. So to fix that, I'm going to divide everything by -1. So we're going to say this is a negative x equal to y squared minus 4y plus 1. Now we're ready to complete the square. And when I complete the square, I'm just going to complete it in terms of y. So we'll go y squared minus 4y. Take my b term, which is -4, divide it by 2 to get -2, square it to get a positive 4, so plus 4, minus 1, and to keep things balanced, since I added 4, I'm also going to subtract 4 back out. Oops, sorry, that was a plus 1. Now, simplifying a little bit, this gives me a negative x equals factor y minus 2 squared, and the 1 minus 4 means a -3. Now, I want to have this just x on this side. I don't want to have a negative x. So let's take that negative. Let's now multiply that back over to the other side, and that will give me the equation a negative y minus 2 squared and plus 3. This equation is now my equation that I am going to work with. So let me bring in a graph here. Shrink this up a little bit. Okay, so first off, my vertex. Vertex is positive 3 for the x. This is now the x coordinate because remember this is with the y. So positive 3 with the x and 2 with the y. So 2, 3, 1, 2. There's your vertex. Now once I know that's my vertex, axis of symmetry is going to run right through that. But keep in mind this is now in terms of y. So the axis of symmetry, instead of running this way, is now actually going to run this way. Because if your parabola is in terms of y, this means you have a horizontal parabola, which means it opens left and right. All right, let's locate our focus and our directrix now. Focus and directrix can be found by 1/4 times a, which means 1/4 times -1, which puts me at a -1/4. This number then gets added to your vertex, which means 2.75, 2 will be my focus, and my directrix I get by simply subtracting that point from the x-coordinate. So 3 minus negative 1/4 means this is at 3.25. The directrix, if your parabola is this way, is an x equals equation. So at 3.25, there is my directrix. Now, I need one more thing here to graph this, and that would be the length of the lattice rectum. Length of the lattice rectum is simply 1 over a. So I go 1 over -1. Now, if you remember from the equations before, it is always the absolute value because we're talking about a distance here, which gives me a length of lattice rectum of 1, which means from my focus, I will go a half in each direction. Now, based off what I have here for my focus, my lattice rectum, and my directrix, I can tell the parabola opens to the left. But just to verify that, remember this A, that's in front of whatever is being squared, that tells you which way it's opening. So since this is negative, this means this opens to the left. And again, let's see how good my parabola drawing skills with a mouse are. Not too bad. Could be a little bit better, but you get the idea. It hits these two blue points for the lattice rectum, hits your vertex, and there's your parabola. So, I know this was only 2 examples. We'll spend lots of time doing practice with these, so bring your questions tomorrow, and we'll see how things go. Have a good night.